So in this lecture, we will be discussing about the programming part of 8085. And basically, we will be discussing about the debugging as well as the advanced instructions which are used in 8085. So first of all, what is debugging? As told earlier also that it is not the correction of the error which is called debugging, but it is the detection as well as the correction of the error is called the debugging. So it's a process of knowing the errors and then use a certain method to correct those errors. Because errors which has been created, it may be due to some reason. You have to find out the reason and you have to correct it. So the process of detecting as well as correcting of the errors which happened in the program so that you are not able to get the desired result, that is called debugging. Now, there are many kinds of the error which can occur. It may be the logic which has been used to solve the problem is wrong. It may be the machine codes which are being used for getting the solution of the program is wrong. The order in which the instructions has to be written, it may be wrong. There are other sources of the error also, because you know that the instructions of 8085 consist of 3 types: single byte instruction, 2 byte instruction, and 3 byte instruction. So if anyhow you are able to forget, if you are using 2 byte instruction and you are able to forget the second byte of the instruction, then in that case also you will be encountered with an error. Similarly, we have 3 byte instructions. There are also that whenever you are going to change your mnemonics code into the hex code, you might have written wrong machine code, due to which you are getting error in the program, error in the result. So there are many sources, there are many various ways by which the error can occur. You are allotting your mnemonics code. Whenever you are converting the mnemonics code into the hex code, then you will be writing each hex code into the memory location. If it is not properly written, if you have to write 3E and you have written 3F, so 3E will be doing something else, 3F will be doing something else. So there are many reasons, and so you have to find that what are the errors which has been occurred. And this error can be found out whenever you are executing a program and you are not getting the desired result. So as far as the debugging of the machine code is concerned, it may be possible that you have selected a wrong code, or you have forget to use the second or the third byte of the instruction. If the instruction is of 3 byte, so second byte and the third byte also taken into the consideration. It may be also possible that you have specified a wrong jump location, because you have seen that in many programs, depending upon the certain condition to be true, you have to change the sequence of the execution of the program from one place to another place. And this change in the sequence of the program is obtained by mentioning the address of that memory location where you want to jump. So it may be possible if you want to jump at 8050 and you have wrongly written in the instruction 80570, then it, instead of jumping to 8050, it will jump to 8070. So there are many reasons. The next reason is debugging of the machine code is not reserving the order of higher and the lower bytes in the jump instruction. Because whenever you are writing an instruction, jump instruction like this, that jump 8070. So it means you want to jump to the memory location 8070. So whenever you are writing this particular instruction into the memory, first of all, you have to write the hex code of jump. Then you have to load the lower byte of the address, and then you have to write the higher byte of the address. So the ordering of the higher and the lower byte is also important. Whenever you have to feed that address into a certain memory location, first of all, lower byte is written and then higher byte is written. Writing data and the address in the decimal, however, we are using hexadecimal. Whenever we are writing any instruction or the data or the address, it is necessary that it should be used in the hexadecimal code. So it is possible that instead of writing the hexadecimal equivalent, you have written the decimal number. For example, suppose you have 10 numbers in the problem given that you have 10 numbers, and you have, out of these 10 number, you have to find out which one is the highest number. So the natural process of solving this particular program is to load a counter by a value 10. Now 10 is a hexadecimal, 10 is a decimal number. So 10 has to be converted into hexadecimal number. Then only it has to be put into the register, which is used as a counter. So it is necessary that you have to be very careful while writing the data or the address that it should be in the hexadecimal form. Another reason may be unable to initialize and end the program correctly, because you have seen that in many programs, before you start writing the body of the program, you have to mention, you have to initialize certain values, either in the form of a data or in the form of a memory pointer. So if you have not initialized that value, suppose you want to work with the 10 number of the data, which is available at 8050 location. So it means you have to read the data from 8050 location. So it means you have to load HL pair by 8050. If you have not done, then whatever is the previous content of 805, whatever is the previous content of HL pair, that will be considered by the program. So it is necessary to initialize the program by the correct values. You have to check 10 numbers and you have written 6. So it will test only 6 numbers and then it will skip from the program. As well as you have to end the program correctly, because the ending of the program can be done in many ways. The best way of ending the program is to check the counter. In most of the program, you have seen that the counter is being checked and then you are skipping or ending your program. So it is necessary that your program should end correctly. So 3 important things which are related to a computer program, whether it is high-level language program or it is an assembly language program, that initialization process must be done correctly, as well as the body text, meaning thereby whatever operation you have to perform, it has to be done written correctly, as well as you have to end the program correctly. So these are the certain way which you have to take care if you want your program to be error-free. Now, as far as the debugging of a program is concerned, normally this debugging consists of 2 parts. The first one is called the static debugging, and second one is called the dynamic debugging. So static debugging is a kind of a operation which we use to perform while writing the program, that it is related with the pen pencil work. Static and the dynamic debugging. Static is related to the visual inspection of the program, that whatever you have drawn in the form of a flowchart, whatever you have conceptualized in the form of an algorithm, and then converting that algorithm into the form of a flowchart, and then converting that flowchart into the form of the codes of the language which you are using for writing, solving your problem. So static debugging is a kind of a visual inspection. It is a kind of a paper pencil work, that is checking the flowchart, whether the flowchart is going correctly or not, or whatever machine code you are using, means the hex code. So all the work which is related with the paper pencil work, that is associated with the debugging. If you have drawn a flowchart and you find that there is a correction which is required in the flowchart because it is not functioning properly, then that kind of debugging is called a static debugging. Whenever you are converting that flowchart into a machine code, whether you have written the correct machine code or not, that is part of the static debugging. So all the paper pencil work, whichever you are going to do for writing a program to obtain the solution of any problem, all that comes under the static debugging. Now, the second one, the second debugging is the dynamic debugging. It involves the observing the output, that is the register content, uh, as well as uh, uh, whether the result which we are getting is correct or not. So dynamic debugging involves observing the output, observing the content of the register after the execution of each register or after the execution of group of the instructions. So paper pencil work, whenever you are going to correct, that is called static debugging. And after feeding the program and while executing your program, whenever you are going to check the result, uh, in the form of a output or in the form of a register content, or while executing any instruction, that is called the dynamic debugging. So uh, static debugging, nothing to explain about that because it is a manual process. And whenever you have done it many times, while solving any problem, you used to check whenever you are not getting the desired result, you used to check that whatever equation you have written or however you have solved, whether the computation you have done correctly or not. The same thing is related with the static debugging. And dynamic debugging contains, there are many tools by which we can do the dynamic debugging. The first one is the single step. Second one is the register examine, and third one is the breakpoint. So let me explain each tool significantly one by one, so that you are able to understand. Single step means the most of the program, whenever we want to execute it and we are not getting the desired result, we used to frame that where the error is coming. So if you have a long program and you are not able to detect that from at which place you are getting the error, so you can go with the process which is called single stepping. Single stepping is a kind of a key which is provided on the hex keyboard associated with the 8085 processor board, which allows you to execute one instruction at a time. That is why it is called the single step. Normally, the program is executed in length. Whole program is executed. But when the whole program is executed and you are not getting the desired result, you may be thinking that where the error has come. So, so what you will do, you have a process by which you can you do the single stepping, and this single stepping provides you the facility to execute one instruction at a time. And after executing an instruction, you can observe the result after the execution of that instruction, so that at each step you are able to verify that at this particular step this should be the result, whether you are getting that desired result or not. If you are not getting the desired result, then in that case you may be able to encounter that what kind of error has been done, whether the code is wrong, whether the data is wrong, whether the code which you are using is wrong. So this can be very easily interpreted while using the tool which is called the single step. Uh, 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 so, and this process can be obtained by using this single step key, which will be able to observe the address as well as the code that are being executed. Whenever you press the single step key, you will be observing that which address is which address is being fetched, at what more memory location it is fetched, and what instruction it is being fetched. So in this way, you are able to spot what kind of error you have done. It may be the incorrect address where you are executing your program. It may be the correct jump location for the loop. It may be incorrect data or the missing code. So single step allows to execute one instruction at a time, and it is going to observe the result after the each instruction. And you are able to find the different kinds of the error which can occur, such as whether you want to jump. Suppose you have executed a jump and you have written jump 8050, Whether it is jumping to 8050 or not, it can be very easily accessible by using the single step. Whether you have to jump to 8070 and you have written 8050, then also it will be showing after single stepping that instead of 8070, you are going to 8050. Or there is incorrect data, because I have already mentioned that if there is a 2-byte instruction, 1 byte will be opcode and another byte will be the data. So it may be possible that you have forgot to write the data along with the instruction. So all these things can be easily accessible by the use of single stepping in dynamic debugging. The second tool which is used for dynamic debugging is the register examine. This register examine, you have seen that in the hex keyboard there is a key which is called examine register or register examine. So whenever you are this key is going to allow you to examine the microprocessor register content, and these register contains the temporary result. So while checking the content of the register, you are able to check whether after the execution of instructions, whether the result which is being stored in the registers are correct or not. So, and all these things are being managed by the monitor program, which will be displaying the content of the register whenever you want it to be displayed. Whenever you are doing the register examine, it asks that which register you want to examine, whether you want to examine A, you want to examine B, C, D, E, which register. And whenever you are pressing that particular key, the content of that register will be available on the LED display. And so by looking to the content of that register, you will be able to assure yourself whether the result is correct up to this stage or not. And this register examining technique can be used in conjunction with either with the single step or with the breakpoint facilities. Now, the third tool which is used for dynamic debugging is known as breakpoint. Uh, in general convention, in general observation, the breakpoint stands for what? Suppose you have a program which is of 30, 50 lines, and you want to check why the result is not coming correctly, whether the result which you have got is not correct. So instead of going through single step, which is a time-taking process, instead of examining the register, what you can do, you can put a breakpoint at a certain level. You divide the total program into different modules. Suppose you have a 30-line program. So after line number 10, you will write a breakpoint. And whenever you are writing an instruction for the breakpoint, it will not execute beyond the breakpoint. So within that 10 instructions which are written, that will be executed. And while observing that execution of that 10 lines, previous 10 lines, whether your program is correct or not. Because temporarily, while executing your first 10 lines, temporarily there will be certain results which will be stored either in the memory or which will be stored either in the register. So while using the breakpoint in conjunction with the register examination, you can check that the first 10 line is correct or not. If it is not correct, it means you have an error within that first 10 lines. So instead of checking the whole program, why not to break the particular program into different modules and execute individual modules so that you will be able to know whether which module is making an error. And for obtaining this breakpoint technique, for applying this breakpoint tool for the dynamic debugging, generally we used to use a software routine that allows you to execute the program in that particular section. And that instruction which is used in the form of a software routine is known as RST instruction. RST instruction, the full form of RST instruction is the restart instruction. And this restart instruction, whenever it is written, it's a service routine which is written at a certain memory location, depending upon the value which is mentioned along with the RST instruction. So the best part of this breakpoint is you can isolate the segment of the program with the errors, which can be debugged with the single flag. Now, once you have uh, uh, utilized a breakpoint for the first 10 lines, so it will not execute the rest of the 20 lines. It will execute only 10 lines. Whenever these 10 lines are executed, you will be able to know at what step what should be the result. And while using this particular single stepping or by using the register examination, you are able to debug the program of the first 10 line. When it is over, first 10 line is now correct, then what you will do, you will debug the program, you will use the breakpoint after the 20 line. So, and then you will be executing the program. And when you will executing the program, by using the single step and the register examination, you are able to find whether this first 20 line is correct or not. And in the same way, you can go. So breakpoint is also a technique to break the total program into different modules and check individual modules whether there is an error or not. And if there is an error, you correct that error by doing single stepping or by the register examination. Now, the errors which we use to get, we have certain common sources due to which we are in need of debugging. So if you want that debugging is not required and in one stroke, whatever program you have written, it should execute correctly. You have to be very careful while drawing your flowchart, while conceptualizing the logic. And then you have to be very careful while you are converting this conceptualization, means the process of drawing the flowchart from the algorithm. And then you have to be very careful while converting the flowchart into the program with the use of the instruction set of the microprocessor. So you have to be very careful while doing all these three processes. And if you have done it carefully, the error will be automatically minimized. But besides that, we have certain common sources of error. The first is to failure to clear the accumulator when it is used to add numbers. In most of the cases, you have seen that whenever you have to add number, whenever you have to compare the number, it is necessary to clear the accumulator. We want it to be clear because it may be possible whenever you are going to start your machine, it is possible that accumulator contains some number. If you are not able to clear that number which is already stored in the accumulator can create a problem to all of you. So for this particular purpose, it is necessary to clear the accumulator while doing any arithmetic or the logical operation. Now the second part of your sources of the error is the failure to clear the carry register, so that you are not able to keep the track of the carry. Because you know that whenever you are going to add two numbers, you will be getting the result in the form of a two. One is called the sum and another is called the carry. Whenever you are storing the carry, you will be storing the sum in a particular register. And whenever there is a carry which is being generated, so that will be represented by the flag register. And whenever you are checking the flag register, you will be able to know whether the carry is generated or not. And if carry is generated, you must be using a certain register to store that carry by incrementing the value of the carry register. So it is also necessary that besides clearing the accumulator, whatever register you are using to store the carry, it should also be cleared with 00. Third one is the failure to update the memory pointer or the counter, because you have seen that once you have read the first data, it is necessary, if you want to continue with the same program, you are in requirement of making the increment, because whenever you have worked with the first data, now you have to work with the second data. So at a certain point, you will be in requirement of incrementing the memory pointer. And if you are using a counter, if one number has been compared or one number has been added, it must be decremented. So if you are not able to update that memory pointer, or as well as you are not able to update your counter, in that case also, there is a possibility of getting the error. The fourth one is the source of the error is the failure to set a flag before using a conditional jump instruction. You are using a conditional jump instruction at a certain place in your program, and while using this conditional jump instruction, you have not used any arithmetic or the logic operation due to which the flag are going to set or reset. Meaning thereby, before using the jump instruction, it is necessary that you must have used the arithmetic or the logical operation due to which the flags are going to be affected. Because flags are affected only by the arithmetic and the logic operation, not by the data transfer operation. So before using the conditional jump instruction, you must assure yourself that you have used arithmetic or the logic instruction due to which the flags are being set or reset. The fifth one is the inadvertently clearing the flag before using a jump instruction. You have used arithmetic or the logic instruction due to which you are going to check that status of the flag, and you are changing the sequence of the program. And in between that too, you have used arithmetic and the logic instruction due to which the flags are being set or reset. And just after that, you have to use the jump instruction. In between these two instructions, you must not use any such instruction due to which the flags are being cleared. So whenever you are using arithmetic or the logic operation, just after that, you have to use the jump instruction so that the clear status of the flag, based on clear status of the flag, based on the exact status of the flag, the jump instruction can work upon. The next one is a specification of a wrong memory address for a jump instruction. You have to jump at 8050 and you have written wrongly 8070. Instead of writing 50, you have written 70. So instead of jumping to 8050, it will jump to 8070. So you have to be very careful. So if you have specified wrong memory address at the jump instruction, then again, you will be able to get encounter with the error. Use of an improper combination of the rotate instruction. While using a rotate instruction, you will be rotating right, or you can rotate it by left. And if you want to regain the status of the data as it is, as you have rotated it left, you have to rotate it right so that the original data can be. So the combination of the rotate instruction should be as good as, so that you will be able to get the correct value. Specifying the jump instruction on a wrong flag. You are doing a certain arithmetic and the logic operation due to which the 0 flag is either set or reset. And you are using an instruction which is checking the carry. So that is a wrong. If you are doing arithmetic or the logic operation due to which 0 flag is being affected, then you have to use the jump instruction to check the 0 flag, not the carry flag. So this has to be, you have to be very careful that the jump instruction and the flag content should be matched together. If you feel that 0 flag is going to be affected, then you will be using a jump instruction by checking the 0 flag. If you are thinking that due to arithmetic or logic operation, carry flag will be affected, then you have to use the jump instruction using which will be checking the carry flag. And this jump is due to this kind of error used to happen very commonly with the compare instruction. Now the explanation. If we want to check the carry flag after the addition of two 8-bit numbers. So whenever we are adding two 8-bit numbers due to which the flags are being affected, especially the carry flag, if the sum is more than 8-bit, carry flag will be set. So we have to take the decision, and just after that, we will be using jump on carry or jump on no carry. But what we have done, we have wrongly assessed. हमने पहले एडिशन किया और एडिशन करने के बाद जंप इंस्ट्रक्शन न यूज करके हमने कोई और इंस्ट्रक्शन यूज कर दिया जो कि लॉजिकल ऑपरेशन या अरिथमेटिक ऑपरेशन कर रहा है. तो जो दो नंबर जोड़ने के कारण फ्लैग पे इफेक्ट पड़ा था, वो उसके बाद वाले इंस्ट्रक्शन के कारण उसके बाद दोबारा प्रभाव पड़ जाएगा. तो अब उसके कारण अगर कैरी फ्लैग सेट होता है, दो नंबर को जोड़ने के बाद, इफ कैरी फ्लैग इज बीइंग सेट एंड उसके बाद हमने कोई लॉजिकल इंस्ट्रक्शन यूज कर दिया जिसके कारण कैरी फ्लैग रीसेट हो गया, तो हमारा तो पर्पस ये है कि if we want to check whether the carry flag has been affected, cleared, or it is set or not, just because of the addition of two numbers, it means jump instruction must be used before any other instruction. So the time when we want to check the flag content due to arithmetic and the logic operation, the jump instruction should be used immediately. In between jump instruction and arithmetic or the logic instruction, there must not be any more logical instruction or arithmetic instruction. That is very important, because otherwise what will happen? The flag